Hello everyone, let us now discuss today's LeetCode POTD problem. Maximum candies allocated to k children. So, we are given with zero indexed integer array candies. So, that means at every candies of I we are having, so these numbers of, at I we have candies of I number of candies, and we need to allocate these candies to k children, but there are some conditions. Each pile, you cannot divide each pile into number of subpiles. Sorry, you can divide each pile into any number of subpiles, but you cannot merge two piles together. For example, if you have two candies here and three candies here, you cannot merge them both and give five candies to a children to a child. You are also given integer k. You should allocate piles of candies to k children such that each child gets the same number of candies. So here the children needs to get, every child needs to get same number of candies. It's not like you give one candy to one child, five candies to one, and four to another. No, every child need to get same number of candies. And there is another condition. Each child can be allocated candies from one pile of candies, and some piles of candies may go unused. So here you might think that if I have five piles, five candies in a pile, I can divide this into two for one child and another two for one child. So that's how you can solve this problem. And there is another constant, maximum number of candies each child can get. Now let us see this example and what is my assumption that I made previously. That I thought something like here the output was 5. So I simply thought that the minimum value, which is 5, will be my answer. But wait a second, and here something where I got a wrong answer here. Yes, here they did something uh, like they gave the output as 3. Now how does they got the output as 3? They took 1 3. So 3 from this pile and 3 one time and the another time here and 3 from here. So 4 times I have distributed or allocated my 3 candies for 4 children. Now there is this is the constant or the wrong assumption that I made, that it is not the minimum value always. But what will be the value now? Let me go through and check it again. Like here, the first thought I can get after taking or after getting the wrong answer is, even if I have a minimum value of 5, I can even take 4. So I can get 5, I can even take 4, I can even take 3, I can also take 2, or either I can take only 1. But why shouldn't I take 8? Because there might be a possibility k would be 8. So at that moment you can only take this pile and distribute it to the, sorry, only one, right? Only one. If k is only one, that means there is only one child, then I can take the maximum value 8 and distribute it. So I can take 1 2 3 4 5 and also even 6 7 8. But every time if I check something like, let me see, let me say that I have 1, till now I have 1. So at this point, instead of going from beginning, let me go from the end, because I need to get the maximum candies. So these are something like allocated candies, right? Allocated candies. So let me come from the end so that I get the maximum first. Now imagine I have allocated 8 candies. So for that I am allocating 8 candies. For that I need to go through these candies. I have 5, I have 8, and also I have 6. Now, the number of candies I want to allocate from each pile is 8. Now I have only 5 piles. As they said, you cannot take, you should allocate piles to k children such that same number of candidates, and you can divide each pile into any number of subpiles, but you cannot merge two piles together. But here I only have 5. So I can only allocate 0 candies from this pile. Now that means I can not allocate to any child from this file. Now, here I can allocate for only one child as I am taking 8 as my allocating candies. So I can allocate only 1 and 0. So totally I got only 1, right? I am only allocating for one child. But let me go through and check for 7. 7 I got. Here the same I can allocate for 0, and I can allocate for one child. Here I can allocate for 0. Then here also I am allocating only for one child. Then I go to 6, 7, 6, 5, 4, 3, 2, 1. But let me go through and check for 6. Here 0. Here there are 6. So I can only take 6. Now here I can allocate for one child. So totally I got 2. But let me go straight to the answer and think how can I get this. I have 5, 4 are skipped, so I take 3. Now 5, so I can take 3 and 8. Here, sorry, here I can allocate 1. Here I have 8. Now, what are the number of children I can allocate with 3 candies? There are 2. Now, what are the number of candies that I can allocate here, which is 6, that are 2. Now if you see, I need only k is equal to 3, and here which is 3, it is having more, which is 5. So at this point I need to go up. When you search in a binary search algorithm, so when I go up I have 5. So here 5 I can allocate for 1, I can allocate for 1, and I can allocate for 1. So totally I can allocate for 3 children, which is equal to k. So this is how you solve this problem. But if I take this all, it would get more time. So what I need to do? Simply I will apply a binary search algorithm. But how? The main important thing is getting the idea of binary search, and the second thing, when to go left or when to go right. Now imagine the same example and same things. Now my mid value will be something like, wait a second, my mid value will be something like 1 plus 8, 9 by 4, which will be 9 by 2, which will be 4. So I am at 4. So imagine, let me write the same thing for 4 also. For 4 also, if I write for 4, so I can allocate 1 here, I can allocate 2 here, and I can allocate 1. So totally I can allocate for 4 children. Now, for this, I can allocate for 4 children, but I want for only 3 children. What I need to do? Where was my answer? It was after this 4. When, so this is the first condition. When I get greater than k, let me check. When I get greater than k, I'll go right. So simply make a note here, I'll go right. But imagine I have something at here. I got a mid value at here, and yes, I will get this something like 8 plus 4, 12 by 2, which is 6. Here I got 2, which is less than k. Here these are these are number of candies, or simply I'll name it as count. The count of candidates, sorry, children that I allocate my current candies, which is 4 previously, now it is 6. So for 6 I can allocate only 2, which is lesser than k. Now my 5 is something where here, so where I need to go, which is to the left. So I need to go to the left, and when it is also equal something like here, which is 5, then also I need to go to the right or to the left. And so this is how we solve this problem. Simply here, let me write the count. Let me write the count here. Now let me take this away and write algorithm from this, right? So count is greater than k, right? Now will I go and search for the infinity? No, right? I can only at max I can allocate for 8. So this will be my maximum element from my candies, and here it will be only 1. The lower value will be 1 and the higher value will be max element in the candies. So I'll allocate low to 1 and high to the maximum element. And why I'll write low is lesser than or it is equal to high. Low is lesser than or is equal to high. I'll run this loop, and here my count will be initialized with 0. And how I get this count? Initially I will be having the mid, which is here the current allocating candies, which is mid, which is low plus high minus low by 2. It is calculated by mid. Now what I am doing every time here, if you see, I am going through every number in candies and taking out the number of candies that I can get, or the number of children I can allocate my mid valued candies. So for every candy in candies, something like C, for every candies in candy, I'll increment my count by C by mid. So why C by mid? Here if you see, I have 3 as my mid value and I have 8. So 8 by 3 will give you how many number of children I can allocate these 3 candies. 8 by 3 will give me 2. So count plus is equal to C by mid, and after this I'll write this algorithm: count is greater than k, then go to the right, count is less than k, go to the left, and here I will make something like answer. So at the last I will return my answer. So this is how the algorithm works, and this is my code. Total candies are the sum of candies. At this 2, 5 and k is equal to 11. When total candies is lesser than k, simply return 0. Low is 1 and high is the maximum element in candies, and my answer is 0. While low is lesser than or equal to high, it is same as the algorithm. Mid is low plus high minus low by 2. Long, don't forget if you are C++ or Java users, uh, initialize everything with long. For int C of candies, I will go through the candies and count plus is equal to C by mid. If count is greater than or equal to k, break there itself. So why I am breaking here count is greater than or equal to k? Because there is no need when I have reached the count of k. So when I reach my target of allocating these candies to k children, then I know no need to go through all the remaining candies. So if count is greater than or equal to k, break there itself. If count is greater than or is equal to k, answer is equal to mid, and low is equal to mid plus 1. Else high is equal to mid minus 1. Return answer at the last. And if you want the code, and it is in the description, go and check it. And if you like this video, do share it with your friends and do subscribe to my channel. You will get POTDs daily on the daily basis, and also the contest solution. Thank you.